Hi, in this lecture, we'll be showing some exploratory data analysis techniques. So the goal is we will learn few items that are required when you do exploratory data analysis, because this is the prior step that will lead you to modeling or any kind of analysis report. So I'll have three parts to cover. The first, I will show how to connect to Google Workspace, because we'll be loading some data from Google Drive, but you can use the same code, just making some small changes, and you can load data from anywhere, from your local machine, or if you have some data on any cloud infrastructure. The second one, I will focus on one very important Python library, what we call pandas, that you will use in your everyday data processing works. We have another video where we have explained some part of NumPy, but today mostly we'll be focusing on pandas, because these are the two libraries you will use extensively in any of your data processing tasks if you're using Python as your base programming language. For this second part, we will use pandas and NumPy for our data processing tasks. And on the third part, we will use Matplotlib and Seaborn. So these are the two tools that we'll learn to visualize our data. And I must mention that I provided here a publicly available exploratory data analysis notebook that I use to actually craft some part of this notebook, and as well as the presentation. So I'll share this notebook through my GitHub repo. So let's get started with the first part. As I was saying, that we will require to load some libraries. You can see that first I'm loading Drive from Google Lab, because this you will require to connect to your workspace. And then there are two libraries I talked about, pandas and NumPy. So here I'm loading those two libraries, and for visualization I'm using Seaborn and Matplotlib. There are some inline commands, but let's not focus on those at this point. Okay. So here I'm actually mounting my Google Drive workspace. So drive.mount, and then you put a path. So you can see that I have some data on my Google Drive workspace, and this is the file name, automobile.csv. And for those who are not familiar with .csv file format, so here we are saying comma separated file, and each entry, you can think it as a row in a table, and the columns are actually separated by comma. This is the file I will be loading, automobile.csv, and you can see that this shows kind of tabular format, but underneath the file format is .csv. I'll share with you the file, and you can open it even with your text editor. So let's go back to the business. So I am loading my data here, and I run my previous cells, otherwise I won't be able to come here. And the first method, so here is I loaded pandas as PD. If I go back, so pandas as PD, so the PD is the module that I will use to do my operations. So pd.csv will give me what we usually call is a data frame. So I name it as df, and when you have that data frame, the first thing usually we do, we run a head method. This will show you the first 5 rows of your data frame. So if you're not familiar with data frame, you can read documentation here. So for example, it returns a data frame. You can see that the data frame class. You can think this as a table. So this is the index column. In simple words, these are the row numbers. So this is the first row, this is the 0th row, that means the first row, second row, third row, and on and on. So the head will give you the snapshot of the first few records. One good thing with pandas is in general you can use the data frame just like your NumPy array, So we were looking at NumPy array in the other presentation, and you can do very much the same kind of operation. So here I am taking the first two rows of my data frame and doing a transport operation. So let's look at. So you see in the first place table headers were per column, but here you see that the table headers became the first column, and the indexes became the header of this table, So we are just transposing. If you run the tail method, you will find the last few records. So that's the whole idea, And on operation you will do quite frequently is you want to look at what are the data types. You as an independent reviewer or manipulator of any data, you have to look at the data and figure out that what are the types are. But you can also take advantage of this method to look at what are the different data types the data frame has identified for each column, So you can see that you have the first column to be an object type, and then the second column is an object type, and then year is integer type. So we are seeing a few different types. One is the object, and then integer, then floating point. So we can quickly connect that the integer and floating point numbers are actually numeric. There is another data type we are referring to what we call object, And here we'll take a little bit time to understand because I put some red text here. If I am saying that careful when you find a column with object data type, So object data type can mean a lot of things that we'll learn moving forward. But in summary, you can quickly connect that these columns were string data type or categorical data type, but Panda is actually referring these to be an object data type, So you might think that, okay, they are referring the string data type and object, or maybe the categorical data as object, but that's not really the case because Pandas has or Python has well-defined string and categorical data type, So when Pandas is referring a column data type to the object, you might have the same kind of data, or you might have some mixed data. You don't expect in one of your table column you will have a different format of data. When Pandas is actually showing you that, okay, this is an object data type, then it is up to you to verify whether the data are of same type or not, Now let's convince ourselves that when we have an object data type, we have to investigate a little bit more and to let you guys know that the object data type takes more memory than categorical or string type, Okay, so now you have a data frame and you have a different way to locate or access your columns, So here we are looking at the make column. You can either just put a df dot make, so that will show you that particular column, or you can also access this way, just put a third bracket and put the column name, you will get the same results. Okay, now we want to find that how many unique values are in that column, or what are the unique values. So recall that we have around 12,000 records, but if you just execute the unique method, then you will find all the unique values within that column, So you have BMW, you have Honda, so these are the unique values within that column, So this is the entire list, but if you run just n unique, then you will find how many unique values are within that column, Let's run the dot column. So this will show you the columns of your table. But if you I'm just calling the len function, will give you what is the length of that list, we have talked about how to access one column, how to get the unique values within the column, how to get how many number of unique values within a column, and we have also seen how to see the number of elements within a list. Now I will be describing one pandas method which is called describe. Okay, so when I call df.describe, it returns me one data frame. It has its table headers and there are some rows, so definitely this is a data frame. But if I first print the shape of the data frame, I will find that the shape is actually 8 by 8. So this is an 8 rows and 8 column data frame. So what does that mean? So here, when we call the describe method, it returns me a summary data frame and its shape is 8 by 8. So there are 8 rows and 8 columns. This is how the data frame look like. So we can say that, okay, in each row we have some statistics like how many records were, and then what is the mean, standard deviation, minimum value, 25th percentile, 50th percentile, and 75th percentile, and the maximum value. So these are the 8 summary statistics we got, but just take a little time. Our original data frame was 11,000 by 12, I guess. Let's look at df save. So this was 12,000 by 16, so here we got a data frame with 8 by 8. So we are not getting the statistics for all the 16 column, rather we are getting statistics for 8 column. So the message is that you will get the summary statistics for those columns where pandas identify those as numeric, either floating point or integer. So here if I count, we have 16 columns and 8 of those columns were identified as numeric data columns. So the summary statistics are for those columns. So let's have a little bit understanding of the values of these columns. Let's focus on this column, highway mile per gallon, and you can see that the mean is 26.6 mile per gallon, and the standard deviation is this value, and then maximum is 354 mile per gallon. So this looks to be natural, but if you look at statistics for number of doors, because number of doors are actually integer values. So if you have mean 3.43, so it is up to you who will decide that whether these statistics for integer values make sense or not. So this concludes my first part.